Hello everyone, and thank you for joining me. In this video, I'd like to introduce the concept of virtual links and cover the effects of defining an area as a totally stubby area. Now to do this, I had to rearrange the topology. I've modified the access layer, okay, so that each PC is situated in its own VLAN and configured according to its VLAN number. And I've done the exact same thing on the right-hand side as well. Now pay close attention to these IP addresses because they're going to be very important later on in this video. All right. Now, in addition to modifying the access layer, I've introduced Area 22 into the equation. Now, Area 22 is situated in a way in which it's wedged itself right in the middle of Area 1 and Area 0. This is a very poor OSPF multi-area design, but these circumstances do arise and are frequent. Well, how come? Well, let's just take a step back for a second. Traditionally, when an enterprise begins the process of selecting an interior gateway protocol, there are many different factors that come into play. However, there are two criteria that stand out. Number one is scalability. You need to ask yourself, is the interior gateway protocol that we're choosing scalable to the size of our business? Can it grow with us? And number two, knowledge level of that particular routing protocol. Now, there is a lot more to it, but generally it's important to take scalability and how comfortable your enterprise is in actually maintaining and administering the routing protocol. Now, the reason this is important is because OSPF multi-area hierarchy can get out of control if you don't have the appropriate OSPF design discipline to accommodate growth in your enterprise. This leads to situations in which your OSPF backbone area 0 potentially hasn't extended itself far enough to be able to reach other areas that do pertain to your OSPF design. Okay? Area 0 is important in OSPF because it is the backbone area. It is the area that is transitive, meaning that LSAs, okay, from Area 2 are allowed to flow in and out of Area 0 into other areas. And this is how your multi-area OSPF hierarchy design and routers that are participating build their database table and build their routing tables. In this particular instance, the LSAs for router 2 will never be able to reach router 5 because area 22 and area 2, which are non-area 0 areas, are non-transitive. So the LSAs get blocked, and this causes a really big problem. And that's where OSPF introduces the concept of virtual links. Virtual links allow you to mitigate this issue. But before we actually get into it, let's take a look at my configuration. So let's take a look at the configuration. As you can see, I've applied the default route on Acme Edge 1, pointing out to Shaw, and I'm originating through the OSPF default originate information always command, the default route into Area 0. Now, I've also configured Gigabit Ethernet 03 to pertain in this particular subnet with Acme Core 3. This relationship is in Area 22. You can see the same hold true on Acme Core 3 and its relationship to the Acme stub. This one here, this relationship here is on Area 1. You can also see that in the OSPF command. Now, I've already applied this configuration, so I just want to take a look at how the network is actually behaving now. So to do that, I want to go into Acme Edge 1 and I want to show you a couple things. So if I do a show IP route OSPF, you can see that I am receiving OSPF updates, but the OSPF updates that this particular router is receiving are the LSAs that pertain to the area that he's in, which is Area 0, and he's also receiving the LSAs that are coming from Area 2. So Area 2, right, and you see this from the IP addresses here of 188.24.65, are properly being announced into Area 0 and being collected by Acme Edge 1 and correctly populated into its routing table. Now, what's interesting is Acme Edge 1 for Area 0 is also now an area border router. It's an area border router for Acme Core 3. So I'm assuming, and we're going to verify this, that the LSAs are properly being populated down to router 9 in this circumstance. So let's go ahead and take a look at Acme Core 3 and verify that. Okay, now there's a lot going on here, but let's just concentrate for a second on the prefixes that originating from Area 2, which is over here. okay, you can see that, again, it's being announced into Area 0. Area 0 is transitive, which means that this area border router here is regenerating those LSAs, and they're known on Acme Core 3 as LSA Type 3 LSAs. And as you can see, they're inter-area routes, all right? In addition to these inter-area routes, which he's correctly receiving, he's also getting the intra-area routes, which are the routes that pertain to Acme Stub, okay? In addition to those, he's getting another set of inter-area routes, which are the routes that are used to actually build the OSPF backbone area, which is the 10.100.100.0 network. Now, the problem that arises is not so much here, but the problem arises on Acme Stub. Because if I do a show IP route, OSPF, Acme Stub does not receive any LSAs. And again, this is due to the fact that because Area 0 is the only transitive area in OSPF, these LSAs that arrive on Acme Core 3 are never regenerated downstream because Area 22 and Area 2 are considered non-transitive in OSPF. Okay, now this is where virtual links come in, because what virtual links allows us to do is it allows us to create a bridge, a link, a virtual link, literally, okay, from Acme Core 3, router 9, all the way to Acme Edge 1, and we're going to extend the Area 0 backbone through this virtual link to router 9, which essentially what you're doing is you're allowing router 9, even though it is not directly connected to Area 0, you are allowing it to pretend like it is. And therefore, once the LSAs that originate through this virtual link arrive on the Acme Core 3, you will see two things. You will see that these particular routes here will turn as intra-area, okay? And you'll also see that this router here now becomes the new ABR for Area 0. Okay, Acme Edge 1 is no longer the ABR for Area 0, Acme Core 3 is, and what that does is it allows the LSAs to then properly regenerate down to Area 5. Okay, so let's take a look at my config. All right, so let's take a look at the configuration. So the objective obviously is to create this virtual link extending Area 0 towards Acme Core 3. And to do that, you would go on Acme Edge 1 and type in the command Area 22 virtual link and then the remote peers loopback address, which in this case for router 3 or Core 3, it's 9999. And you would do the same thing on the other end on Core 3 pointing towards Acme Edge 1. Now I've applied this configuration already and I want to just take a look to see what's going on here. So as you can see, the neighborship is up, okay? So it's up on the OSPF virtual link interface 2 in full. So if I do a show IP OSPF route OSPF, we can see that the routes that were originally considered OSPF inter-area routes, which were the routes that were used to create the OSPF backbone, are now identified as intra-area routes. And the reason why they're intra-area routes is again because we have this virtual link that LSA type 1s are allowed to pass through, and therefore Acme Core 3 is recognizing these LSA type 1s because he feels and pretends like he's physically connected to Area 0, but he's not. It's logically through this virtual link, so you can see how these update packets change. Nothing changes with respect to these particular updates because the 188.16.85 is down here, and he has an interface that's pertaining to Area 1, so he's eligible to reach or receive these LSA type 1 packets. However, what's interesting is that the 188.24.65 are still considered inter-area routes, okay? So basically what that means is that the only prefixes that are allowed to actually pass through this virtual link are the routes that pertain to Area 0. Okay, the other inter-area routes, like so for these ones here that flow in, they're still being recognized as inter-area routes in the traditional sense with the traditional OSPF adjacency that it had before the virtual link was set up. So having said that, let's go back to the stub and let's take a look at what the stub sees. So I do show IP OSPF route OSPF. What we see is we are now connecting to area 0. Okay, so we are now connecting to area 0, which means that this router here now becomes the area border router, and the area border router regenerates the LSA type 1s received from area 0 as LSA type 3s, which we see here. Okay, and also because this is an area border router, okay, he's actually regenerating also the inter-area routes arriving from area 2. So you can see how they're arriving here and being populated. So now this Acme stub has the ability to reach the 188.24.65 subnets all the way on the other end. Now, we're not done here because essentially we do have some cleanup that needs to be done here. Because just because we've extended the area 0 backbone over to core 3 does not mean that we do not summarize. Okay, summarization is extremely important because it reduces, again, the database table, which helps reduce the time it takes for the SPF calculation to take place and select the best routes and insert them into the routing table. Okay, so it's very important to summarize. So going back to my configuration, what we're going to do is on Acme Edge 1, we're going to summarize the 10 network. As a matter of fact, this is an error. We're not going to do that because Acme Edge 1 is no longer the area border router for area 0. Acme Core 3 is, so therefore that command is going to go under the Acme Core 3 router. So we're going to summarize the 10.100.100 to a /24, okay, instead of propagating the /30s. And we're going to do the same thing with area 1, 188.16.80. So he's going to summarize these routes, and he's also going to summarize the area 0 routes. So let me just go ahead and apply that. So we're going to do a config T. Looks good. Perfect. And what we're also going to do is we're going to go on Acme Core 2, right? And we're going to summarize here as well, because we want to summarize those access router prefixes as well. All right. Okay. Now, this update should have taken place immediately. So let me just go on to show IP, the Edge 1, do show IP route OSPF. And look at what we have here. So we have the 188.24.00 network that is being summarized as a /21, being advertised by router 4. So router 4 is responsible for announcing that /21. And if we take a look at Acme Core 3, we can see that Acme Core 3 is still receiving that /21, which is over here. All right, perfectly. All right. Now, what's also happening is that if I go on Acme Edge 1, show IP route OSPF, he is also getting the /20, which is being summarized by the ABR over here. So the ABR is advertising out correctly the /20 into the area 0 backbone, and router 4 is announcing out the /21 correctly in that circumstance too. If I go under the stub and we take a look at the 10.100.100 network, which was used to build the area 0, there you go. So we can see that the area border router core 3, right, the area border router here is advertising the 10.100.100 network, okay, which is a /24. And we can also see that he's receiving the /21 from area 2. He's also receiving that /21. He is the owner of the 10.16.85. That's why you're not going to see it as an OSPF update. You'll see it as a directly connected link. Having said that, I'd like to move over to turn area 1 into a totally stubby area. Okay, so to do that, I have to go under router OSPF 1. Oh, config T router OSPF 1, and I'm going to go area 1 stub no summary. All right, so that's going to cause an adjacency change. Let's go on core 3. Let's see what happens here. Config T router OSPF 1 area 1 stub no summary. So now we're defining it. What the? No. Pardon me. Area 1 stub. Oh, sorry, I don't know what happened there. All right, so I've just done that. So the adjacency is going to come back up with router 5, between router 9 and router 5. And let's take a look now at the routing table. And there you go. So what essentially happens is that a totally stubby area blocks all LSAs from entering into area 1. So inter-area routes known from router 4, that's /21, and the 172.16.64/30s are no longer in the ACME stub. But what happens is that the ACME Core 3 replaces it with an LSA Type 3 default route. Okay, and this again is a tactic to minimize your routing table, minimize the database table, which essentially allows for fast convergence and faster path selection process. This is a suitable solution because you're in a single homed environment, meaning that there's only one link to ACME Core 3. So the default route is a correct pattern that would satisfy this need. Okay. I hope you enjoyed this video, and thank you for watching.